Now we are going to move to the data structures that we have in Pandas. We have three major data structures in Pandas, just like we have in Python, for instance, list, tuple, set, or dictionaries. The first one is series. The second is data frame, which we have slightly seen in the previous section. And the last one is panel, which is a 3D container of data. We are not going to talk about panel for this course, since this is just a brief introduction to how you can use Pandas. Now for series. Series is basically a one-dimensional array with homogeneous data. Just like you have in Python list, where a Python list is 1D, series is also 1D. And a series allows different various data types, like integers, strings, floats. However, the series must be of the same data type. The reason why it must be of the same data type is because there are certain mathematical functions that you can perform on a series. Take, for example, when you have a list of numbers, you can use that to exploit and see the mean of the list of numbers, or the median, or the mode. However, if you have a list that contains numbers, integers, or let's say numbers and strings, then there's no way you can perform a mathematical operation like finding the mean on that list. This is why series exist. They must be of the same data type, and you can perform series of operations on those. For data frame, we already know that they are two-dimensional and they are heterogeneous. How do we create a series in Pandas? As we see here, we have declared a variable and assigned it to a list of numbers. And as we see, the numbers here are of the same data type. Given this, and after we have declared this as a variable, we can then create another variable and pass in our alias, which is PD, with a dot series. Remember, in data frame, we use dot data frame. However, here, because it's a series, and as you see, it is homogeneous, we can pass in the value of the variable into the argument, and we can definitely print what that looks like. Given this, we can use NumPy, for instance, to calculate the mean of our series, or do some other mathematical or statistical operations on our set of data points. If you want to see how you can do this using NumPy, I also have a course on NumPy. Now we move to data frame. As I mentioned before, it's a tabular data structure that helps us to organize our data into rows and columns, creating like a 2D dimensional layout.
Hello there. If you have enjoyed this course so far, kindly support me and subscribe to my YouTube channel. Subscribe will also help you know when newer courses are released. Thank you for subscribing. I do hope you have. Let's carry on with the course.
A data frame, you can see it as a table or spreadsheet with rows and columns. In our data set, we know they can be of different data types. Given this, we can also conclude that we can see a data frame column as a series. So one data frame column can be seen as a series. For example, if we look at the one that we created here, we can see this age as series, we can see name as series, we can see city as series. And for example, when we have a Pandas series that is age, we can calculate the mean age for our data sets. And as we have seen before, this example, this is just repeating that same example and showing us how to create a simple data frame from a dictionary. However, I would also like to highlight that there are different ways we can create our data frames. We can create our data frames from CSV files, from Excel sheets, from JSON files, in fact, from HTML files, and even from databases like SQL. And we can also create our Pandas data frame from picos. And this number 1 to 6 shows us the different ways that we can do that. The read CSV, for instance, allow us to read a CSV file as a data frame. And to CSV means that we want to save a particular data frame as a CSV. The same extends to Excel files. We can read Excel file as a data frame, or we can read a data frame into an Excel sheet, that is Excel format. Same thing can be done with read JSON to JSON, read HTML to HTML, and SQL and the likes. For example, we have created a DF sample, which is from our data that we have created from a dictionary here. And we can see the data frame is here, and we can actually export that particular data frame as a CSV using the toCSV function. One good thing when we are using a Jupyter notebook is that when we alight on a function, it can actually tell us what this function stands for, as we see here. And this exercise basically helps us to save our data frame that we have created as a CSV. If we want to save it as an Excel sheet, then we can use the toExcel, and then we change the extension here to the Excel extension. And I would like you to try an exercise to read a CSV, to read another file with read CSV, and also read an Excel sheet that has been provided for you in this course. In the next module, we are going to go into exploratory data analysis with Pandas, which is basically the meat and potatoes of this course. We are going to explore this sales data. We'll look at the different columns that we have in this data set. Like, for example, we have the quantity ordered, we have the price for each quantity, the sales that was made, the date that it was ordered, the status, if it was shipped, it has been cancelled, the month it was made, the quantity ID, the year, and several other columns that lies in this sales data. We are going to be using Pandas to explore this data and also manipulate this data in different ways. I'll see you in the next section.
Hello there. If you have enjoyed this course so far, kindly support me and subscribe to my YouTube channel. Subscribe will also help you know when newer courses are released. Thank you for subscribing. I do hope you have. Let's carry on with the course.